Hi, my name's John. Welcome to another Sunday night nightcap. This Sunday is the first of the month, so it's monthly draw time. Unfortunately, there's only me here, so I'll have to do the draw. So we'll get the bucket. There's quite a lot of names in here now. Have a good ferrage around, one up the bottom somewhere. Right, just one this time. Right, the name I've got on here is Mike Smith. Right, Mike, all you need to do is get in touch with me via email. That's my email address up there, and I'll get this person out to you as soon as possible. I'm going to do another draw this month, and the prize this month is going to be January's prize because it wasn't claimed, and I did email a lot a few times, so I'm just going to redo that. I'll show what those items were a little bit later on. If you want to enter the draw, all you need to do is send us an email. That's my email address up there, and all I need is your name, like your full name, like John Mills, not just John. Your name goes into the bucket. If it's drawn out, you win the prize. Simple as that. I've got a nice set of bore gauges, snap gauges. There's an Extreme plasma cup. Extreme actually sponsor my YouTube channel. There's also an R8 boron head. This was given to me pure and simply to give away because I've already got two. I've got one I use and one that's basically too good to use. If you want to enter the competition, all you need to do is send me an email, and that's my email address across there. All I need is your name, like your full name, like John Mills, not just John. I had lots of comments on the Mako spring alarm I did last week about how you tighten the spindle in. The part I didn't show was this. That's the original spindle shoulder there. It did have a small hex on it, which you could have gotten a socket in. But what I've done is I've gotten a 16mm cap head bolt. I've cut the cap head off and welded it onto there, so you'll be able to tighten it, no problem, into the nut on the far side. A lot of people expressed concern about the nail lock nut. I'm going to drill it and put a castellated nut on, and that'll be the job finished for them. This is a bearing cap of a Fowler traction engine. That's where the oil goes, as a wick goes in there which feeds the brass bush underneath. And unfortunately this one's got a big bit broken off there. I don't know how it got broke off, but it's been broken off for a while because there's actually red paint in the crack. So I've got to try and repair that. I thought about machining it flat and making a piece, but I've decided to use some silicon bronze and sort of bronze welded together. I'll build it up. I want a bit of carbon there so I can put that carbon or the graphite there and lay bronze behind there, and then we'll be able to machine it back to shape, and hopefully it'll be good to go again. I mean, it's a 100-year-old cast, and it's the trouble with it is it'll be full of oil. The oil and shite will boil out as I try to weld it, but we'll just see what we can do. I'll give it a bit clean up with a wire wheel first, and then we'll get some preed into it and then have a go at welding it. I'm going to put a little bit of warmth into it just to take the chill off. Not to melt the base metal, just to get a sort of sticky. Once we get the bronze onto it, That's going in nice. A lot better than I thought. Right. I've got this one, I've got the tongue around, and I'm using all of it. Right, that's basically it all welded up, but did weld quite nicely. We'll let it cool down naturally now and then knock the thick off with a grinder, then machine it. I've put plenty on, you want to make sure you put plenty on, you don't have to come back and start putting any more material in, but that'll do the job quite nicely. I've repaired quite a lot of castings using this method and I've always had good results. I'll show the setup on the welder, the settings I use, because a lot of people are interested in what settings I use for particular jobs. With me it's just trial and error, more error than trial normally. This is the main welding set I use. It's an Artec 260 amp AC/DC set. It's got 9 memories or 9 places where you can store a welding setup. This one is on number 8. This is the one I use for silicon bronze. I'm actually welding it on AC. So I'll go through the various settings. Start at the beginning. Pre-flow gas, I've got no pre-flow. Start amps 25 amps. No upslope because I'm using a pedal. Main welding amps I set at 200 and I use 200. It does go up to 260. Down here on AC I'm using 10% cleaning. So I've got the balance set at 10%. AC frequency 70 Hz. Downslope, no downslope, because once again I use a pedal. End amps 5 as low as it'll go. Post flow I've got set at 9 seconds. That's organ that comes out when you've finished welding. You can weld or use silicon bronze on DC. What I find on dirty castings, that AC with the balance set right back does clean it and gives a very good result. The torch is a CK torch with a different handle on because I put a heavier power cable in. It's a water cooled torch. Once again I use a Artec water cooler. That's a 2.4 tungsten. I use 2.4 for everything except real heavy stuff when I will go up with 3.2. And obviously I'm using pure organ. I've mounted the bearing cap in my mill vise. It's not the most rigid mounting, but it's basically all I can do. Normally that's the machine face, that one there and that one there. Normally a machine face would go to the fixed jaw, but if I did that you couldn't see us machine it. So I've got a little bit of MIG wire, aluminium MIG wire, TIG wire behind there. It's tightened down solid onto that, parallel onto that jaw there. All I want to do is level this face up. So I'm just going to take it nice and slowly and see what happens. I may need to drop the cutter down through the hole to clear that bit there, but at least I can have a little go at it and see what it actually machines like. It normally machines not too bad, except where you get near to the base metal, and if you've had a little bit too hot and alloyed it, it forms this alloy that's hard, not very nice at all to machine. That's actually clay mill in there, that's why it's a little bit jerky. This one's into the direction of the rotation, so it's a lot better. It is machining quite nicely. Happy with that. There's a fair bit to come off, but it's better than to re-weld it and put some more on. That's the last thing you want to do. Just gently chip away at it until we get the desired result. It's always a lovely colour, this stuff, when you machine it. Just about it all machined off now. One fine cut and then a little bit of hand dressing to do under here. Final finish on that with a grinder, and that's it. That's it done. Quite happy with that. I'm very happy with it. No blowholes or nothing in the bronze, which is pretty good. I've changed for a carbide cutter. For the last cut, running a lot faster. With the carbide cutter fared much better, and I managed to take that all the way down to original metal, so those two dimensions are now right. Just got the corners to sort out and then hand do that bit with a little die grinder. Well, that's quite a nice repair. This recess in the centre is for the oil to circulate around, so I need to grind some of that out and then just blend those bits in. Right, I'm going to leave it at that. Those are the bits there, the important bits that need to be finished off on the job. But at least the height's are right and it looks good. Looks very good. Very pleased. Yeah, that's nice in there.